Hello class, today we're going to jump into chapter 10, do a little bit of geometry. We'll look at area and circumference. So our objectives today are to use area formulas to compute the areas of plane regions and solve applied problems, and use formulas for a circle's circumference and its area. Now, let's look at the area of a rectangle and of a square. Now, looking at the rectangle, the area A of a rectangle with length L and width W is given by the formula A equals L times W, length times width. It gives you your area of your rectangle. Now with a square, each side is the same length, so the area A of a square with one side measuring S, linear units, is given by the formula A equals S squared, which is essentially still the same thing as length times width, but here the sides, which is what S stands for, are the same, so you could just square it or essentially multiply it by itself. Let's look at example 1. Solving an area problem. You decide to cover the path shown in bricks. Find the area of the path. Now, there are several ways to solve this. Let's show you the way that I would go about solving it. So we begin by drawing a dashed line to divide the path into two rectangles. Okay, so if you notice in the picture here, we drew that dashed line vertically, basically here, to divide this into two rectangles instead of one. So we have a new line here making this two rectangles. Then we'll use the length and width of each rectangle to find its area. The area is found by adding the areas of the two rectangles together. So if we look at the first rectangle, we see we've got 13 feet here and 3 feet here. So it's a 13 by 3 foot rectangle. So we see those, like I said, respectively here and here. Now if you multiply 13 times 3, you get 39. And that's where the 39 feet squared come from on rectangle 1. Now rectangle 2 might be a little bit trickier. You've got a 6 feet here and a 3 feet here, okay? But that 6 feet doesn't span this entire distance. We got to add this distance that we closed this rectangular in with. That distance is 3 feet, so we're really doing like a 6 plus 3 here. Okay, so this is like 3 foot here, so 6 plus 3 gives us 9. We're looking at 9 feet by 3 feet for that rectangle. 9 times 3 is 27. So we got 39 feet squared plus 27 feet squared give us a total square footage of 66 square feet here on our path. Easy enough. Alright, let's look at the area of a parallelogram. The area A of a parallelogram with height h and base b is given by the formula A equals b times h. Okay, the height of a parallelogram is the perpendicular distance between the two sides of the parallel sides. It is not the length of the side. So take note here when you look at this parallelogram, this length here is not your height. The length that's your height is your vertical here, the one that makes the 90 degrees. So this is your height, your vertical distance, not your diagonal here. So make sure that you find the correct height. Okay, now the reason this works is you can see this triangle here that's created by this dotted line to find your height. If you were to take it and basically cut it off, it fits perfectly here to make you, and I know my drawing is not perfect, but it fits perfectly here to make what is essentially just a rectangle. And you can see that in the picture here. If you took this here and pasted it back over here after you cut it off, it would make a rectangle that was b times h. Okay, so let's find the area of the parallelogram. The height here is 4 centimeters. The length here is 8 centimeters, so we're really just looking at 4 times 8. 4 times 8 is 32. They're centimeters, so it's centimeters squared. Simple enough. Now let's look at the area of a triangle. The area A of a triangle with height h and base b is given by the formula A equals 1/2 base times height, 1/2 b times h. Just like the parallelogram, we have to find the height here. The height is what's going to drop down, hit your base, and give you that 90 degrees. Okay, so if we find our height here, we know our base, we can just do 1/2 base times height. Okay, so let's look at an example. So here it gives us all kinds of measurements on this triangle. This is find the area of the triangle. It gives you a measurement on this side, it gives you a measurement on this side, and it gives you a measurement on the base, and then it gives you the height measurement. It gives you all these measurements to see if you know which ones are important. Okay, remember our formula is 1/2 base times height. So all we need is 1/2 times the base, which is 16, times the height, which is 10. I don't even need to know the 10.5 or the 14 for this particular problem. So I'm just doing 1/2 times the base, which is 16, times the height, which is 10. So I basically got 80 meters squared after I multiply. Now, we're going to jump on over to the area of a trapezoid. The area A of a trapezoid with parallel bases A and B and with height h is given by the formula A equals 1/2 AH plus 1/2 BH. Okay, so A is what we're calling the base here, and B is what we're basically calling the top here. So they're both bases depending on how it's really flipped, but you just have the A and B being your length of your parallel sides here. And then obviously you need to know your height as well. Okay. Or you could rewrite this formula 1/2 H times A plus B. Whichever one feels more comfortable for you or that you're used to. You might have learned this before. Whichever one you're used to if you've already learned this. Otherwise you can do 1/2 H times A plus B. Just add them together. Okay, so let's look at this. It says find the area of the trapezoid. If we're using the formula 1/2 H times A plus B, then all we're going to do is take the two parallel sides. We're going to add them together. 46 plus 32. We're going to multiply that times the height. Here's the height. That's 13. And remember, you have to multiply that by a half as well. So add the bases, multiply by the height, and multiply by a half. Boom, boom. See that your area here is 507 feet squared. Now let's get into circles. A circle is a set of points in a plane equally distant from a given point, its center. The radius r is a line segment from the center to any point on the circle. All radii in a given circle have the same length. The diameter d is a line segment through the center whose end points lie on the circle. It is twice the radius. All diameters in a given circle have the same length. Alright, so let's find the distance around the circle. We want to find the circumference of the circle with diameter equal to 40 yards. Okay, so when it's saying the diameter is 40 yards, that means the length here that spans the entire circle and goes through the center is 40 yards. Okay. Now, we need to know the formula for circumference. Okay. If you don't know the formula for circumference, some people commonly know it as circumference equals 2 pi r, but we're not given the radius here, we're given that diameter. So it's actually also equal to pi times the diameter. Okay, so either one of those formulas is valid for circumference depending on how you learned it. But we have the diameter here, so we're just going to use pi times the diameter to find the circumference. Okay, so all we got to do is multiply pi. Remember, pi is 3.14 approximately. On a TI calculator, you'll have the button for pi, so you can be a little more precise. But we're really just looking at that times 40. So we're looking at 40 pi yards, or 125.7 yards approximately. Now the circumference, what it gives, let me see if I can change the color of my pen here. So the circumference, what it gives is the distance around the circle. So if I started right here, and I walked all the way around the circle and stayed exactly on the edge, which I'm doing a terrible job of doing here, and come all the way back to my starting point, and like I said, stayed perfectly on the edge and I didn't wobble like my hand did here, then that's how long it would take to get there. It would be 125.7 yards approximately to get all the way around this circle and back to your starting point. That is circumference, the distance around. Okay. All right. So let's look at this. Change my pen color back. It says, which is a better buy? A large pizza with a 16-inch diameter for $15, or a medium pizza with an 8-inch diameter for $7.50. Okay, the better buy is the pizza with the lower price per square inch. All right, so we got to figure out what the price per square inch is here. And it's not as straightforward as it may seem because we're messing with circles. The radius of the large pizza is 8 inches and the radius of the medium pizza is 4 inches. Okay, how did we get that? How did we get that, Mr. Shipes? Okay, what we're trying to do here is we're trying to find the area. Okay, if we find the area, we can use that area to find the price per square inch. Okay, because you have to find area to find square inches here. All right, now the formula for area is what we're going to have to find. The formula for area is pi r squared. You can see us using that here for the medium and the large pizza. Okay, so what that means is I need to know the radius of each of these pizzas respectively. It says a large pizza has a 16-inch diameter. A diameter spans the entire circle, but we need the radius. And remember, the radius only spans half the circle. Therefore, if it's got a 16-inch diameter, its radius is half of that. So for the large pizza, that's 8. For the medium pizza, it has an 8-inch diameter. Remember, the diameter spans the entire circle. The radius only spans half the circle. Half of 8 is 4. That's where these radiuses are coming from. Okay. So, for the large pizza, if we want to find the area of the large pizza, we need to do pi times 8 squared, okay, which gives us approximately 201 inches squared. The radius of the medium pizza we said was 4 inches, so we need to do pi times 4 squared, which gives us approximately 50 inches squared. Now, we're not quite done yet, okay? We need to find the price per square inch for each of those pizzas. So what we're going to do is we're going to take the cost of those pizzas. Remember, the large pizza cost here was $15. The small pizza cost was $7.50. Or sorry, medium pizza cost was $7.50. Okay, so we're going to take that $15 for the large pizza. We're going to divide it by essentially the square inches of that pizza. So let's look at this. $15 divided by 201 inches squared gives us a cost of about 7 cents per inch squared. Okay, this is really what we're looking for here. If we do the same thing for the medium pizza. Medium pizza costs $7.50 and it spans 50 inches squared, which is approximately 15 cents per square inch. Okay? Now, which one's cheaper? Which one's the better buy? Obviously, the large pizza is the better buy because it's cheaper per square inch. So you're getting more pizza for less money with the larger pizza than you are the smaller pizza. What the Pizza Chain's trying to do here is make it look like it's the same, because 16-inch diameter for 15, half of that for $7.50. But because the area formula doesn't play like that with the circle, it's not a direct ratio there, then, you know, you're really not getting as good a deal as you think right there. You're actually getting a much better deal here with the larger pizza than you are the smaller pizza. You're paying less than half. That completes this chapter 10.4. Go on and complete the associated assignment. Let me know if you have any questions, comments, any issues with it. And come back right here for chapter 10.5, and I will see y'all then.